Okay, so in this video we're going to look at finding exponential equations from given data. The first one's going to involve a little story here problem. So here we're told that a wolf population is growing exponentially. Okay, so again, very important that we establish that either by them telling us or it's known in some way, right? It's not exponential, right? Then this technique will work. So they tell us it's growing exponentially. In 2011, 129 wolves were counted. By 2013, that's 2 years later, the population had reached 236 wolves. Write the equation representing the population n over time t. Okay, all right. So again, they want a specific format. So in terms, they just tell us how to name the function, right? That's all this means. N over time t, so n number of wolves at a given time t. So that's going to be exponential, so it's going to look something like this. Now, for problems like this that involves, they give us years, a nice place to start is instead of having like t be like 2011, which you can, it's fine. What I like to do is I'm going to count t from, in this case, let's say the year 2000. Okay, and again, this is simply a point of reference. So the year 2000 is year 0, right? So 2011, our initial point would be when t is equal 11. Right, so when t is equal to 11, that's our independent. So we have 2 points here. Our independent would be in 2011, right? And our dependent, our output, is 129 volts. Okay, and then the next measurement is 2 years later, right, at 13, and there we have 236 volts. Now again, I chose 2000. There's nothing stopping you from saying, oh, what if I wanted to choose 2010? Go ahead and do that, right? And in that case, that would be 1, 129, and 3, 236. Again, these are just reference points, right? It gives us a place to start. And you can, again, just keep 2011 and 2013 if you want. But I chose here, so we'll leave it as this. Right, now I know a couple things, right? This is telling me 2 values, right? So I know that n of 11 is equal to 129, right? Input, output. And n of 13 is equal to 236. All right. Okay, now one thing I'm going to do is I need to find a and b. Right. The first thing I'm going to try to do is I'm going to try to find the value of b. All right. So the way I'm going to do that is I'm going to look at the ratio of these values. So I'm going to look at n over 13 divided by n over 11. And then you'll see why I chose to do this, right? So I know what these are equal to, right? This is 236. This is 129. These both, I believe, can be divided by 3. So let me see, 236 divided by 129. Let me get that in lowest terms. Oh, I guess 9. Okay, no, never mind, not divided by 3. So that is in lowest terms. Okay. All right. Now the reason I want to do this here, as you'll see, n of 13, if it's an exponential, that means we have a times b to the 13th and a times b to the 11th. That's going to be equal to 236 over 129. Okay. Now here, notice what's going to happen here. A divided by a, I get a nice reduction to that, simplifies to 1. And also using properties of exponent, if I'm dividing, I subtract the exponents. 13 minus 11 is b squared. All right, now we're cooking here, right? Now we can solve for b, right? Rather easily, right? Now it's b squared. Well, I can do that, right? I can just take the square root of both sides. And then I'll get b to be, I'm going to have to round. I believe those are not perfect squares. So I'm going to take my calculator here, and I'm going to put second square root, and just plug that in, 236 divided by 129. And here I'm going to use 2 decimal places, right? unless explicitly stated how many decimal places, 2 should be just fine. So we have b. Now again, normally when we're taking the square root of a square, we would do plus or minus. But here it's exponential function, so b is always positive. So we'll just take the positive value, 1.35. This is equal, not some strange looking other symbol here. All right, b is equal to 1.35. All right, it makes sense as well, right? The population is growing, so it makes sense that it is a value that is bigger than 1. So what do we have so far, right? So far we have n of t to be equal to a, I still don't know what that is, 1.35 to the power t. Okay, now, not quite done yet, but I'm almost there, right? How do I find a? Well, choose any one of these points. Which one? Doesn't matter, right? So here I'm going to choose n of 11, so I'm going to say a times 1.35 raised to the 11th power is equal to 129. All right, so here I'm just using this fact. All right, I just need one of them. You could have chosen that one as well. And then here, now I just divide, right? So a is going to be 129 divided by 1.35 to the 11th power. And again, work for our calculator. Right, actually, yeah, okay. All right, so here we have 129 divided by 1.35 raised. I got an older calculator here, so make sure you usually to open a parentheses. Actually, you could have probably done it without the parentheses, but here to the 11th, now we get 4.75. And I'm going to round, since a does represent the initial population, I'm going to round to the nearest whole number. Okay,